occlusion design. So, if you see the four most common problems, you can see that the relationships are very complex. Right? One problem could be the risk of the other. For example, if your restoration is ill-fitted, you cannot sit down and cause hyperocclusion. If your hyperocclusion restoration may fracture or debunk, right? So we're going to talk about these problems and these causes. We break them into four clinical steps. Okay? Scan, preparation, bonding, and occlusion design. And the first one I want to talk about is scan. So here may come to question. Why is scan? Why is it not preparation? So it's because in the traditional way, we take a primary impression, right? We want the study cast. So in the digital, it's all the same. When patient comes in or before I prep, most of the time I like to take the primary scan. Okay. So for a scan, Dr. Tsao also talk about framework scanning. What is framework scanning? We often see that the pictures like this, right? So this means there's no distortion, very accurate. But what does it mean? The red area means the deviation happens. So in this picture, the deviation happens in the posterior teeth, right? Does that mean the distortion happen in the molar area? No. Actually, distortion happens most in the anterior area. Why is that? Because our intraoral scanner is like a camera capturing pictures, and it wants to mapping the pictures together. So if there's no landmark, no information, it will happen distort. Okay. So the anterior area, the occlusal side of the anterior area is incisal edge, right? The incisal edge is very thin. It doesn't provide enough information for our scanner, for the software. And the buccal side of anterior teeth are very flat, right? Compared to posterior teeth, compared to occlusal side of the posterior teeth. Okay. So we want to solve this problem. We want to solve the problem of scanning distortion. So our team, Dr. Michael Tsao, published this framework scanning in 2015. So how do we perform framework scanning? Now, first of all, we start from the occlusal side. But right after that, we turn to plateau side. Okay? So we start from occlusal side about 3 seconds, and we turn to the plateau side, and finish the plateau side and go back to the occlusal side again, 3 minutes. And then we scan the occlusal side, incisal edge, occlusal side. And again, occlusal side for 3 seconds, sorry. And we turn to buccal side, and we finish buccal side and go back to occlusal side. Okay? So the concept is that we want to create 3 main framework. What are they? Occlusal, plateau, and buccal. So most of the manufacturers or the dealers tell us to scan from which side? Occlusal, right? Occlusal. But the problem of occlusal side, I just told you, when you're scanning the anterior area, the distortion happens. So this is why we start from plateau side. Okay, so what's more? Plateau side, there's a more attached gingiva, right? Keratinized gingiva that cannot move. So compared with buccal side, there are so many mucosas, and it's not good for the soft tissue to mapping the images. Okay. So first of all, we are start from plateau side, occlusal side, buccal side. Okay. So what is the result? And this is framework scanning. You can see that the deviation is just a little deviation with a lab scanner. You know the lab scanner? The lab scanner is a bigger one, right? You can scan the model, so it's very accurate without distortion. And those are inaccurate. What are they? 2014 instruction, 2016 instruction. They're instructions from Dance by Sarona. So you can search videos on YouTube, just type full mouth scanning, intraoral scanning, Dance by Sarona, and in their official video, it shows you how to scan. They can scan from the Plato side, go buckle, go Plato, go buckle, Plato, buckle, Plato, buckle, Plato, buckle, Plato, something like that. So actually, we call that arbitrary scanning. Do you understand? Just scan wherever you want. Don't follow this sequence. Okay. So if you do the arbitrary scanning, your error is very big. Okay. And we don't have an R&D team to check our scanning every time. So how can we check the scan is distorted or accurate? Here's a simple method. Just open the byte and see the distribution of occlusion force. So if the left side and the right side is balanced, we can make sure that we have some confidence with the scan. Okay. So this left side, you can see the red. Red means heavy occlusion. Yellow, heavy. Green, light. So what? Here is no occlusion because they are abutment. Okay. So basically, these occlusions are balanced between left side and right side. Okay. And last year, several doctors from America also published their suggested scan strategy, and they called linear scanning. So if you do the arbitrary scanning I just mentioned, you scan to buckle, lingual, buckle, lingual, buckle, lingual, buckle, lingual, to finish the whole arch. It actually is arbitrary scanning. So you can see that the occlusion is unbalanced. Here the left side, right side, left side. But if you do the linear scanning, basically they are balanced. Okay. So what is linear scanning? The concept is all the same. Just finish 3 framework. Okay. But certain doctors start from the bottom side, and I just told you the shortcomings of the bottom side. Okay. And 3Shape also have their suggestions for full mouth scanning. They start from occlusal side. And they also know the problem of occlusal side of the incisal edges. So you can see here, when it comes to the anterior area, go to buccal, lingual, buccal, lingual, buccal, lingual, and finish buccal, finish Plato. So in the anterior area, it's a little like an arbitrary scan. So there's an article in Search Digest. This is our blog. This article is talking about the full arch scanning, and it is written in English. So if you are interested, just check it out in Search Digest. And recently, I do the research. I do the study with these 3 scanners. The study I just showed you, we only use OmniCAN, but this time we use read content with these 3 scans. So can I ask you a question on that? Who use 3Shape 3S? Please raise your hand. Okay, so I should say something good. Who uses Sarah OmniCAN? Okay, thank you. Me too. Who uses Playmaker? Nobody. Oh, okay. So I said, Dr. Michael Tsao, I want to do this experiment, and he said, okay, I will give you these 3 scanners. So here comes a Playmaker, 3Shape, and lots of Sarah OmniCAN. But actually, I'm not so happy because I have to do about 100 times of scanning. Yeah. But our R&D department is more suffer with me. So I just tell you the result because we don't have so much time. This is 3 shape. If you're doing an arbitrary scanning, the deviation is bigger, a little bit. But actually 3 of these has no significant difference. If you are using plate makeup, you can use a 3 shape suggestion. Okay. Remember that start from the occlusal side. But arbitrary scanning is still the highest deviation one. If you're using ceremony can, use our framework scan. The deviation is only 6 micro compared to that scan. So, many masters suggested that if you are doing full mouth scanning, if you are doing full mouth rehab, don't use intraoral scanner. Everyone heard that before? Please raise your hand. Yeah. So is that true? So actually, you know that this is a full mouth rehab case, and this is a full mouth splinted one-piece tent. And when it mill out, we put it on the model. The model we scan, we do intraoral scanning. Okay, we use this model just for photo. So we make this tent from intraoral scan, and this is a non-prep tent, non-prep one-piece tent. When we put on the model, it just fits without any adjustment. Okay, so if you are doing full mouth scanning, don't use intraoral scanner. It's right, but it's wrong. Why? I can make a conclusion. Scan needs practice and scan needs strategy. If you don't have a strategy, if you don't know how to scan, please just use silicone. Okay, it's better. But if you know how to scan, if you know the framework scanning, you can try it. Okay. The next question: should we polder? So if you are using shape, do you polder? No? Anyone polder? Sarah? Okay. Yeah, okay. So not every time. Okay, so let's see this study. This is an interesting study. They put a tooth structure here and many different material here, and this is a flat surface here. Okay, but after scanning, will that be flat in the computer? So some of them become higher. What are they? They're amalgam and gold. So maybe that they are too shiny. The reflection is so strong. So the scanner thinks they are taller than they actually is. And some of them are lower than the tooth structure. What are they? They are composite. 3 of them are all composite. So maybe it's the composite is too translucent. So because the deviation. Okay? And these are similar to the tooth structure. What are they? The first one is zirconia. The second one is beta mark II feldspar. The third one is empress cat, the lucite material. Okay? So actually, these 2 glass ceramic has a similar optic property to tooth structure, right? So we know that if you don't polder, sometimes you will get some scanning errors there. Okay, so if you are doing full mouth scanning, my suggestion is you should polder a little bit, but you don't know because you don't know where the composites are or where the amalgam or metal crown, metal inlay, gold inlay, and even more. Maybe the patient's enamel is very translucent, and it can also cause a problem. So here comes another question: how to powder? So to me, I always, if I want to powder toward the tooth, at least 7 centimeters. Okay. So this is how I powder. And right after powder, I take a picture. It looks like this. Just a thin layer on the tooth, okay? And this is quite enough for the scanner. And it won't make the tooth much bigger, okay? Okay, so the second step, we do the preps. In digital dentistry, preparation is more critical. And we are talking about the reduction first. And here are the preparation guidelines from the manufacturers. Okay, so we can take a picture of this. Okay, so after we know that, how can we achieve? Okay, in the patient's mouth, we can check the reduction, like we using a mirror and ask the patient to bite together and see from different aspects. So after that, this is my result. Anyone use CEREC know what is that thing? It's thin, right? Insufficient thickness. And what is the red area mean? Heavier occlusion. So the thickness is not enough, but the occlusion is too heavy. So it means I need to prep more, right? My reduction is not enough. Okay. So the technician will come to me and say, hey, Dr. Brian, there's some problems here. Should you re-prep or you want me to mill it out? So the bad thing of digital is that in traditional way, if the lab technician called you, he will say, no, I'm sure I have 1 millimeter reduction. Right? I will say that to the technician, right? But in digital, the computer just tells the technician, okay, just tell everything. So you cannot say anything for yourself. Okay? So after I put it in the patient now with the articulating paper, it's just the same as you see in the screen. So every time we mill out the restoration, we can see this result. What you see in the screen and what you get in the patient's mouth. So with CEREC, we just do a little occlusal adjustment. And the proximal the proximal adjustment, usually we don't need to do that because it just fits. So what's the correlation between preparation and bonding strength? We know that if the reduction is not enough, you will be like me, right? You will have some problems. But if you prep too much, is that okay? Of course not. So this study followed about hundreds of veneers to see what made them failure. So they break all veneers into 3 groups. One is that the preparation is all in the enamel. The second group is that I have over 70% of enamel. The third group is the enamel is less than 70%. So the result is the survival rate, 100% enamel is equal, and not equal, but it doesn't have significant difference with the 70% enamel. But once your enamel is less than 70%, your survival rate will significantly reduce. Okay? So we know that if you want to do a veneer, please preserve 70% enamel on the surface. Okay. So this is one of my cases. Come in my room with chipped incisor and a fractured veneer. Okay. My prep, and you can see the margin is very clear in the software. And this time we use the Beta Trilex 4, and this is a feldspar material. And you can see the natural gradients is already in the block. Okay, everyone knows the Trilex 4, right? So I don't need to introduce it. Okay, so in the software, like real life, we can arrange the position of the restoration. So you can make it more darker, more lighter, or more gradient or less gradient. Okay? And we can make some surface texture on it, okay, the morphology. And after mill, you can see the gradients. So just do some more surface texture with the curve. So the gradient is just like the neighbor adjacent teeth. Okay, so we know, of course, enamel bonding is better than dentin bonding. But what if it's all dentin bonding? So this study compared the bonding strength of superficial dentin and deep dentin. And they use 3 different bonding systems. And the results are all the same. Superficial dentin has the highest bonding strength. The deep dentin has the lowest bonding strength. Okay. So even though we are prepped into dentin, we still want to keep it in the superficial layer. Okay. So what we are doing when we actually prep down the teeth, actually we are prep down the bonding strength. Okay. So I don't want to prep too much because of the bonding strength, but I don't want to prep too less because of the lingual thickness. So here comes the staging preparation, aided by the scanner. How is it? In the traditional way, we do the reduction. After reduction, we do polish and finish, and the last step is scan or impression or design. Okay. In staging preparation, we just add 2 steps: primary scan and check occlusion, and do the polish and finish. Okay. So in the primary scan, you can see that here's some red area, and the software tells you that there's insufficient clearance. So you prep more and go rounding and finish. So the first, we do the gross preparation, we do the reduction, and we do the primary scan. And the software will tell you where the insufficient thickness is. Okay, so check the clearance, and polish and finish, and rescan. So in the final scan, we just need to delete this small area and rescan this small area. So it just take a little more time. Okay? So how does staging preparation help us in the anteriors? This is an old filling, and after prep, after remove all the decays, I already prepped so too much, and I feel sorry for her. So, but I still preserve the incisal edge. But I'm not confident with doing that because I don't know whether it has enough space or not. So I do the primary scanning, and I ask my technician to come to make a proposal, make a design for me, and see if there's enough space for the veneer or not. And the technician said, yeah. And when she's designing, I'm doing the polish and finish. I still polish my margin, finishing my margin. Okay, so it doesn't waste any time. Okay, so actually the dentin is only here. So I have, of course, 70% of enamel. Okay, because if I want to do the incisal reduction, how much tooth I take? About 1 minute, one millimeter or 1.5 millimeter, right? It's a dangerous amount. So this aesthetic is still achieved because I'm sure there's enough room for the veneer. And you can see how fit the veneer is. And after bonding, you can barely tell the margin. Okay? And it's the final result. So with the staging preparation, we know that we won't cut too much, we don't prep too deep, but we have enough space for the ceramic. Okay. The next one is surface smoothness. So if the prep is smooth enough, it's not smooth enough, there will be some problems in both traditional and digital dentistry. Okay? But in traditional, the technician will help us to try in, right? Try in on the models. So when it comes to our hands, it already no big problems there. But in digital, we don't even have models to try in. Okay? So we don't know how is that until we put it into the patient's mouth. So the preparation, the surface smoothness is very important. And so the microscope is very helpful with digital dentistry. Okay? So here's a sharp angle here. What means sharp angle? It means the angle is sharper than the milling burr. Okay? So if anything is sharper than the milling burr, the machine has two ways. They have two selections. One is to mill less. Mill less. So it is under milling. One is to mill more, mill over the sharp angle. So we will get the result like this. So what's the problem with under milling? Yeah, not fit, cannot try in, cannot totally sit down, right? And what's the problem with over milling? Too much cement space, yeah. And maybe there's no enough ceramic thickness. Okay, so this is what over milling like. The holes are punched by the burrs. Okay. And after milling, again we can see exactly the same result with the screen. So here I prep two tools under microscope, and one is sharp and one is smooth. Okay, let's see the difference. And from the lateral side, you can also see the sharp angle here, and something like this. Okay, so there's a big difference, right? There's so much space here, and it is quite fit. Okay? So, in digital, if your prep is not smooth enough, there cause lots of problems. So that's over mill. And do you still remember what's under mill? It will cause your restoration doesn't sit down. Right? So if you have under milling, use sharp angle with under milling, the restoration cannot sit. With over milling, you have open margin here, but at least other sides are very fit. Okay? So if your prep is not very well, what is better? Which one is better? Maybe over milling. But there's still some gap here. Okay? So preps for digital is more critical. When I went to take some microscope prep course on Ukraine, near to Russia. You know Maxim? Maxim, right? Yeah. I went to Maxim this year, and I told him, Maxim, your prep is so wonderful. Why don't you use Kecken? And he told me, yeah, I already bought a CEREC. Maxim also using CEREC, but not so much because he's still trying. So after I learning from Maxim, I come back to Taiwan and I do some preps. I found that the crown has suction, because it's quite fit. Okay, so the microscope is always a good friend of Kecken. Okay. The next one is bonding. So I heard that many people say that the ceramic is not so strong. The feldspar is only 160 megapascal. The Emax, okay. Do you know how much strength is Emax? Flexural strength of Emax. 500? Okay, so yeah, now if you search it in the Ivoclar website, it's 530. But actually, 2 years ago, they say that they're 370 or 360. So why is that? It's the same material, same composition, okay, same formula, but the strength of Emax grows up with ears. Okay, it's a mystery. We don't know why. Okay, it's not important. So, how can we compare the strength between old ceramic and PFN? No, PFN, the veneering porcelain is just 120 megapascal. It's weaker than any kind of Kekan material, right? But the metal is so strong. But the PFN, if the porcelain fracture happen, you know the whole bridge are failure, right? And the tiles are very easy to break, right? You can use your hand and you can use your head. Does anyone want to see me break it? No, why? Because it is bonding with concrete on the ground, right? So we cannot break it anymore. So same thing as our ceramic. Ceramic is not quite strong, right? It's not quite strong. But after proper bonding, it will be strengthened. Okay. And we already know the difference between enamel bonding and dentin bonding. Okay. The dentin bonding has its shortcomings. So how to improve dentin bonding with IDS? Right. Everybody know IDS? Okay, so I should skip this chapter. Okay, so I just emphasize two things. Okay. Of course, isolation, remove water. So we should have a nice isolation to see the whole margin. And then apply the adhesive, construction dry, and maybe you doing some protecting resin or not. Okay. The important thing is that after light cube, you should use a glycerin jelly, like KY jelly, to make the oxygen inhibition layer completely polymerized. Okay?
Is the KY jelly water-based right?
Yeah. Yeah, water-based. Yes. Yeah. You mean the KY jelly affect the polymerization of? Yeah. Yeah, we know that if the resin is cured in the water, the oxygen is maybe it's 10 times than it in the air. But actually, yeah, glycerin jelly is water-based, right? But I think it needs some study. I didn't do the study, but most of people now doing the oxygen inhibition layer with this. So I'm not sure with this, but now current they do that. They do remove the oxygen inhibitor layer by KY jelly. Yeah. Okay. So after applying the glycerin jelly, another 10-second curing is enough. Okay. And after the second curing, we should re-prepare the enamel margin. Why is that? Because when we are applying dental adhesive, it's very difficult to control, right? So maybe you'll cover some part of the enamel, but that is not what we want, because we want the enamel to be aged, to be bond until the final cementation. Okay. So we don't want to improve the dentin bonding, but sacrifice the enamel bonding. Okay. So it's very important to re-prep the enamel margin, to reveal the enamel margin covered by the dentin adhesive agent. Okay. And the end is scanning and impression. Okay. So of course, some dentists ask me, should we do IDS first or scan first? Of course, IDS first and then scan. Okay. So the two things are important in the IDS procedure. Okay. And scan with the rubber dam. How to scan with the rubber dam? Before we apply the rubber dam, do the primer scan. Okay. So this will be easier. Of course, you can do the total scan after rubber dam application, but it will be difficult for the software to match. Okay. And we prep, we isolation, we do the IDS or CDO, and then we crop. Where should we crop? Again, just a little abutment and adjacent teeth half of adjacent teeth is quite little. Okay. And we rescan. Okay. So it will be like this. So what's the benefit of scan with the rubber band? It's not just because it's cool. Okay. Yeah, isolation. If I remove the rubber band, I should do the isolation again. I should use the retraction cord, tape long tape. So with the rubber band, we can see the entire module very clearly. Okay. And the surface is very smooth to avoid under milling and over milling. Please. I scan with the rubber band, just want to see the entire margin. Okay. So after I remove the rubber band, I can scan by registration. Or you can scan the by registration before rubber band application. So if it's a sedation patient, I do it only for him or for her. I even don't need to remove the rubber band. Okay. I scan the bite, upper jaw, lower jaw, prep, scan after rubber band, do the final scan, and I still apply the rubber band because he's sleeping. It's okay, right? So about 1 hour, I deliver the restoration. Okay. So most of the time, I take the bite buckle scan after the removal of rubber band. Okay. This is trying and this is final. So what I skipped is imitation, right? This is suggested by Pascal McNair, but my suggestion is that don't use the diamond burr because it's too violent. Because the IDS there usually is very thin. If you use a burr to grind it, maybe it's removable, completely removable. Okay? So you can use sandblasting or use previous powder with a brush. Okay? So if you are delivering it in a very little time, you can only use previous powder because the bonding strength is still quite good because the polymer of the resin are still active. Okay? But if you deliver the restoration after 1 week or 2 weeks, you should use sandblasting to make some mechanical bonding. And do the selective etching of enamel and apply the adhesive, both IDS layer and then the enamel layer. Do the restoration and cement together and co-curing. Okay? So after adhesive bonding application, don't like you. Okay? Don't like you. Or maybe your restoration will not sit down. And this is because of IDS, so that I can do the co-curing. If you didn't do IDS, the bond strength is better when you do the separate curing. Okay? The last part is occlusal design. You still remember this too? So what am I going to do with this? I'm going to grind the surface. Right? So this study is going to show us how much damage we are doing to the ceramic when we grinding the surface. So here are different materials like Emax, Beta Mark II, and so on. So they use a different burrs, a 75 micrometer, 54 micrometer, 18 micrometer, and this is the strength after grinding. Okay. So let's take an Emax for example, because maybe it's the most similar one. Okay, so once you grind Emax with an 18 micrometer diamond, 18 micrometer is very fine, right? Very fine diamond burr. Okay? You grind with a fine diamond burr, and your flexural strength become 210 megapascal. or a 42% reduction. So it's very scary, right? You just use a 5 diamond per and cause half of the stress reduction. So let's make a comparison of these three. Emax, if we use the coarse diamond to grind these three material, Emax, lithium R2, and